The most basic building blocks of Euclidean geometry are three things: points, lines, and planes. They're also undefined terms. We can describe them, but they don't have a strict mathematical definition. So what's the first building block? It's a point, and that's simply a location in space. And even though for drawing points we just put a little dot beside right there, it really has no dimension. This little dot that I drew, no matter how small I make it, does have some dimension. We usually label points with capital letters. So that'd be point A, point B, point C. Now we say a line is a set of points extending in two directions without ending. So a line is all of these points stacked right next to each other going in two directions. A point has no dimension. A line has one dimension, and we usually label them with lowercase letters, like this would be line L. Now if I have 2 points on a line, say point A and point B, then I could write that as line AB, or I could say line BA. Either one of these would be correct for labeling this line. A plane is a flat surface on which a line joining any 2 points on it would wholly lie. So they have 2 dimensions, and we usually draw a plane like a parallelogram. It represents a piece of a plane floating in space. So if I hold up this piece of paper right here, this is like a plane. Okay, it's not the entire plane. It's a piece of the plane that contains this paper. Okay, and then you can draw a line in that plane. All right, now you could also draw another line that intersects the plane, goes through it, and comes out underneath. Okay, line L is in plane X. Line M intersects plane X. Okay? Space is a set of all points, and it's three-dimensional. That's the world we move in, is space. Collinear points all lie on one line. So if I have a line and I have points A, B, and C on that line, they are collinear. Point D is not collinear with A, B, and C. Coplanar points are all on the same plane. So I can have 1, 2, 3 points that are coplanar, and out below it I could have another point that's non-coplanar. It takes 3 coplanar points. It takes any 3 points can make a plane. Okay, any 2 points make a line. Now what happens when 2 lines intersect? Okay, well, I'll draw a line this way, and I'll draw another line this way, and their intersection is a single point. What happens when 2 planes intersect? Okay, this is kind of tricky to draw. Let's see how I can do it here. So there's one plane, there's another. Okay, and they're coming down like this. And this plane is going out like this. Okay, so what's the intersection? Their intersection is actually a line. Hope y'all can visualize that. Okay, so when 2 planes intersect, we get a line. What happens when 3 planes intersect? Well, one of the easiest ways to visualize this is think of a corner of a room on the floor and the ceiling, and what happens, let's say you've got the ceiling of a room, and then you've got the floor underneath it. Okay, and then you've got a wall. So, well, I didn't do a very good job. Okay. Anyway, you get the idea. Okay. So, whoop. There we go. The intersection of 3 planes, stop that, is a point. So if I have this plane, and the ceiling, I get that point right there. If I have this plane, and the floor, I get that point right there. So when 3 planes intersect, you get a single point. So let's do some true or false. Does line PF end at F? Okay. Actually, no. These arrows indicate that lines go on forever and ever in that direction, and they go forever and ever in that direction. So line PF does not end at F. That is false. True or false? Point S is on an infinite number of lines. Okay. Here's point S. I can draw one line there through it. Oh, look, I can draw another line there. How about this line? Whoop, missed it, didn't I? How about this line right there? Yep. How many lines do you think I can draw through point S? Well, I can draw an infinite number of lines. So this is true. A plane has no thickness. True or false? Well, let's go back to our piece of paper here. Even this piece of paper has a little bit of thickness in it. A true plane has absolutely no thickness. So this is true. True or false? Collinear points are coplanar. Well, if I have a bunch of points that are all on the same line, I can always draw a plane that contains that line. For example, the plane of my laptop screen contains that line, so they are coplanar. That is true. True or false? Planes have edges. Well, even though we draw a plane to look like a parallelogram and it looks like it has edges, remember we're just drawing a piece of that plane. These edges, I even shouldn't say edges, these directions in the plane go on forever. So this is false. True or false? Two planes intersect in a line segment. This is kind of a tricky question, okay? Because remember, if we go back to our picture here, where we had these two planes, okay, it looks like they intersect in a line. That's true, but do they intersect in a line segment? Remember that a segment has endpoints. Since the planes go on forever, their intersection goes on forever. So this is false. True or false? Two intersecting lines meet at exactly one point. Okay. There's one line. There's another line. True. They intersect in exactly one point. Lines can't curve around and hit each other in another spot. So that is true. Is it true or false that points have no size? Well, that is true. Okay. Points have no dimension, no size. And last one, can line XY be denoted as line XY or line YX? And the answer is yes, it can. It doesn't matter. Since the lines go in both directions forever, it doesn't matter which letter you put first.